All right. Good afternoon. My name is Xiong. I'm a professor at Emory University. I'm really happy to be here and help co-organize this workshop. So thank you, Rachel, for the great introduction. And also, you touched upon some of the challenges of applying DP to health data, and also your personal journey, which is very inspiring. So for the next few minutes, I will try to get a little bit more technical in terms of applying DP to the health space. And maybe my goal is to try to set up a shared lens for this workshop, how we can use DP to support health and genomics research, and how we can move from formal privacy guarantees to kind of more responsible deployment. So I find a good way to organize the space of supporting DP for biomedical data and applications might be this data and task matrix or view. So depending on what kind of data we want to protect and what kind of task we want to support. So along the rows, we have different kinds of data that each of them has its own challenges. We start with the health records and patient timelines. So for those of you who work in the clinical settings, these are kind of longitudinal data for each patient about their visits, their encounters. So these are oftentimes longitudinal and very irregular in terms of time points, and also very sparse, and may have missing data, as Rachel mentioned. And then we have genomics and different kinds of omics data. These tend to be very high dimensional, and especially genomics data is highly identifying, and also a unique thing about it is that it may reveal family relationships. So who is the expert on this? He will tell us more about that later. And then we have different imaging data and text data, these multimodal data, that not only by itself is a challenge, but also we want the alignment between these modalities can be also a challenge. And finally, we have the behavioral and public health data. Several talks are going to be on this topic. This might be related to people's locations or contact network or population signals that we're interested in. So regarding this data, we might have different tasks that we want to support. And DP can play a role here. So this can be supporting the sharing of the data sets and sharing some insights or statistical summaries of the data sets, or building models, including predictive models or just foundation models. And finally, we may want to share synthetic data as a proxy if the raw data cannot be directly shared. So for each of this cell, depending on any kind of data or any kind of task, our challenge or the takeaway point, the key question is, how can we preserve the biomedical signal that are useful while providing a formal privacy guarantee? So given this task and data view that kind of defines the scope, what the next question we want to ask is, how can we apply privacy or differential privacy in this space? A useful, again, I think, view to organize, to think about this privacy space is to think of it as a life cycle kind of framework, because privacy is not a one-time thing. When we want to release a table, we apply differential privacy, or when we train a model, we apply differential privacy, then we're done. So it is a continuous privacy property that we want to manage. So I want to organize this through this life cycle view. We want to start, for example, with scope and govern. So we want to first understand what needs to be protected and what consent, what policies we have, and what kind of a privacy budget we are talking about or we should set and we should manage. And then after that, we can apply our differential privacy mechanisms or algorithms that we have a lot of tools about to try to protect and build in this process. I think this is a little bit, am I using the right one? Back a little bit? Okay. Is it good? Okay. So after we build these differential privacy mechanisms, equally important is we want to validate and audit our mechanisms or algorithms to make sure it does preserve the utility and also has the privacy property we are designing for, and as well as other properties like fairness. Cynthia is going to talk about broader ethical use of the data. And only after that, we can probably release and deploy these statistics, insights, models, and tools. And finally, even if these are released, the privacy does not stop there. We want to monitor, and because the data keep changing or the use case might change, the patient's consent might change. So we want to monitor it and make sure the correct consents are expected or managed, and data needs to be unlearned, they can be unlearned, and so on. So across all of these, the governance is actually cross-cutting. We need to make sure the policy, consent, and privacy budgets and all of those are ensured. So to start with the scope and govern, our first stage in our life cycle is how do we choose the privacy unit? That was mentioned early on. So this is a very key concept in differential privacy. In DP, we often talk about neighboring data sets and the unit that needs to be protected. And turns out this is a deceptively hard question for the healthcare and genomic data, because this can be, in the healthcare or genomic data, this can be a patient's record, or can be just a single visit in a clinical visit, or can be just one symptom, or can be a simple label. Or in the genomics case, it can be a family as a unit. So what are we trying to protect? So we need to define this under different contexts. And the related, but slightly different question is, what is the scope of the protection? Even given one record as our unit, maybe not all of the information are private, maybe just partially sensitive. There's some features are sensitive, some modalities are sensitive, some others may not be. So how do we make sure we have the protection scope defined, properly defined? And finally, is the level of protection. What kind of level do we want to achieve? Do we want to achieve a uniform protection for all of the patients? Or some patients might have different preferences or requirements. Different institutions may have different requirements. How do we actually ensure, or how do we enable this kind of personalized or selective protection? So the takeaway is that the biomedical data are heterogeneous and very context dependent. So our privacy protection should be also context aware. And after we properly define the scope and the governance context, then we can actually apply our DP algorithms and mechanisms to enable different tasks. So this can be, we release private insights, we release private models that are trained with DP, or release private synthetic data that are generated by DP algorithms. And across all of these, one key point I want to argue is that these kind of safeguards should not be one size fits all, as we mentioned earlier. So we can apply, again, different tools like label DP or feature DP if we only want to protect the labels or only want to protect partially sensitive features. Or we can use personalized DP to enable personalized privacy preferences for different patients. And after the protect and build, equally important is the validate and audit. If we think about DP, it can be a proactive theoretical guarantee we apply during the training or data release. It gives us a language, a very strong language to claim the privacy, and also gives us a worst case bound. However, at the same time, in practice, the real systems, we may want to understand the actual or practical empirical risks. So that requires the auditing. And we can use a variety of attacks that the community has developed, including membership inference, data extraction, and all of these attacks to try to understand the empirical privacy risk. So this gives us a complementary understanding of how realistic or how, what's the empirical risk of these systems. And after these validation and auditing, then we can release what we intended to release, like the models or statistical summary or insights or synthetic data and so on. However, the privacy does not stop there. As we mentioned, because the data might change, the use case might change, and because the data might be used in different studies, and patient may give different consent for different studies, so we want to make sure we continue to monitor the system and make sure the different consents and different policies are satisfied. So one example could be the consent withdrawal. Patient can withdraw their consent for certain studies, and in this case, we want to remove the influence of the data or record from the trained model, and retraining the model is, of course, expensive, so there's this machine learning that a lot of people are working on in the community to try to do this in an efficient and effective way. So given that, I hope now we have somewhat of a rough framework that help us to frame some of the talks or most of the talks we have coming up. For today's talk, we have a talk session and a panel. So they're going to touch on the data sharing, the policy, the legal aspects, and also the deployment panel, where we're going to share some lessons from the real deployment. So this strongly connects to the scope and govern and the release and deploy. And then we have the joint TPDP health session, where we're going to dive deeper into some of the algorithms, which connects to the protect and build. And then for tomorrow, we're bringing in additional perspectives, including genomics data and auditing and synthetic data generation. So these are connecting to the protect and build and also validation and audit. So I want to leave you with some questions that on my mind, and also I want to leave you with these questions through the workshop. As you listen to these talks, maybe you can think about what is the privacy unit that's appropriate for different tasks, for different data sets, and what is the utility evidence for different tasks? How can we be sure these provide sufficient utility and align with the clinical applications? And finally, this governance over time, not just for building models or generating data, we want to think about this privacy over the timeline. So as you listen to the talks, if you can think about what challenges are remaining, what are the next steps, so hopefully we can have breakout sessions tomorrow after the talks so that we can have more in-depth discussions. So with that, hopefully that gives us a general framework. And as I mentioned, genomic data gives very unique challenges because they are highly dimensional and uniquely identifying. So Xiong will take a deeper dive into the genomic data with DP.